Okay, this is video number 2. It'd be a lot shorter video because I'm also pressed for time myself. I've been here making videos too long. This one is a continuation of what comes from lesson 6.3, and it's called the average mean value. And when we look at a function, the function itself has a tendency to be represented by like a flat line. So this is an idea of visually representing what average means. So I'm using the function like we used before, the square root of x. And I'm also going to use what numbers we got from before. You can see it over here in the Desmos slider, that we have from 1 to 6. And so just thinking about it, like, what is the square root of x? Well, at 1, it's 1. And at 6, that's, okay, hang on, 3 point something? No, 2 point something. Square root 6. We get 2.44. So I'm just going to sketch those in really quickly. 2.45. And this is the function f of x equals square root x. All right. So the question is, how do you determine for that interval what the average height of the function actually is? It's kind of the idea that we were seeing in 6.1, where we were drawing the different intervals at different sizes, and sometimes there was a rectangle that stuck out above the graph, and sometimes there was some that how much was above and below was an issue. So this one is, how do we determine the average height of a function from A to B? And it uses a formula. Okay, so in this case, A is 1, B is 6, and if we look at the area under the curve, so that's all of this area shaded in, it's approximately an area of 9.131. We're really just going to take that value and we're going to multiply it by, well, this fraction. Think about what we did when we had average in the past. Average is add them up and divide by number of numbers. I don't know why I'm talking like that. Anyway, add them up and divide by the number of numbers. So the thing that I'm trying to say here, get rid of that garbage, is that from 1 to 6, there's a whole range of numbers. So this is the add them up, and now we need to divide that by the spread, the amount of numbers from 1 to 6. So really, take the average and divide it by take the area and divide it by b minus a. Okay, at 1.82624, etc., somewhere like right here, 1.86 is the average height. There's a little bit above. I mean, the line goes a little bit above our function. It goes a little bit, under our function. But the complete area of this, so I'm going to sketch it in red. Unless you're colorblind, I'm sketching it in gray. But the area of this rectangle is supposed to match the area of what's under the curve. This is kind of nice to represent an entire region of a graph with a rectangular area, a rectangular shape, and then you can imagine like taking this leftovers and filling it into here, cut and paste type style. This leads us to the actual formula. This is a big idea. This is the mean value, like star this. This is the mean value theorem for definite intervals. All right, this is major. This is like, remember this. Anytime something gets a theorem, like it's a proven fact that it works, and we need to know it. So we have this notation. F is continuous. We have a closed interval from A to B, and F is in that interval. It's continuous, because we have to have that. Then that means that there is a point C somewhere, x equals C. So it's all about finding that location, like finding this point right there, okay? Such that f of C equals the average. So we had this similar question come up with like the average slope, like somewhere along the curve. Now we're talking about like the average height in an interval. And this is the mean value theorem for definite integrals, kind of like we had a mean value theorem for derivatives. Know them both, put them on a flashcard and study them. All right. I have some more things I need to share with you, but I want to do that in person when I'm back on Tuesday. So thank you so much for watching. Please make sure to work on your Math Excel and send me any questions or emails or have them ready to go with questions when I come back.